Today we're going to be discussing titration. So we've already talked a little bit about acids and bases in class, and today we're going to be discussing what titration is and how to solve some titration problems. Now in this case, titration, I have a little bit of a picture over here of the setup for titration. You can see over here. Now titration is a way to determine the molarity of an unknown acid or base. Now for today, we're going to be mainly focusing on having an unknown acid, but it does work both ways. But to just simplify this with our examples, we're always going to be talking about it today in terms of an unknown acid concentration. Now, when we're determining an unknown acid concentration, we're going to use a known base, which means we need to know the concentration of the base, what the base is, and the volume of base that we end up using. And secondly, we'll need an indicator. So when we're talking about this, we have a conical flask down here, we have a burette, and then in this conical flask, if this is our, if we're talking about an unknown acid, our unknown acid will go down here. We do need to know the volume of that. That's easy for us to figure out. And then we'll have our base up here and we'll have a known concentration. As we twist this, we'll add more and more base to this, and eventually our indicator will change color. Now, what we're going to have in our little setup. We're going to have our flask down here, and we do need to know when we're putting in our unknown acid, we do need to know the volume of this. So let's say that this is 50 milliliters. We need to know that this is 50 milliliters of, let's say, HCl. We're going to add a couple of drops of an indicator in there, and there's a wide variety of indicators. Today I am going to kind of use phenolphthalein as our example indicator. Now phenolphthalein will turn pink once we've reached our endpoint. So we would put a few drops of phenolphthalein into this HCl. Now this hydrochloric acid is going to be acidic right now, and at acidic pHs, phenolphthalein is clear, so we're actually not going to see any change once we add that indicator. Then we'll have our burette up here. And that's my little drawing of a burette. And as we go through, we will have sodium hydroxide up here. We will need to know what the concentration of that sodium hydroxide is. And as we do our experiment, we will use more and more sodium hydroxide. And we continue doing this until this turns pink down here. I know that looks a little bit red, I don't have a pink pen here, but we're going to pretend that that just turned pink. We are going to measure, in this case, if we started up here, I just erased the line, but if we started up here, we're going to see how much volume of sodium hydroxide we used in order to get that to turn pink. So we're going to mark before starting the titration how much sodium hydroxide we have in our burette. We're going to drip a little bit in, drip a little bit in. We'll be swirling this flask as we do it to mix it. And as soon as this turns light pink, I know that this is red, but as soon as this turns light pink, we're going to mark how much sodium hydroxide we used. Now, if we do this, we now know a couple of things. We will know our volume of sodium hydroxide, and we already knew our molarity of sodium hydroxide. So let's say that we used 10 milliliters. And let's say that this was 0.5 molar NaOH. 10 milliliters, not 10 liters, that would be a lot. 10 milliliters of sodium hydroxide. Now we can convert this 10 milliliters into liters pretty easily. We've done metric conversions. And in this case, we have 0.5 molar. Now, if you remember back to when we first learned about molarity, molarity is moles of solute per liter of solution. If we take this 10 milliliters, convert it to liters, and multiply it by the molarity, we get our moles. And so that's what we can do in order to get our moles of base. Now, you might be wondering, well, how do we get our moles of acid? And that color change is important. Now, with that color change, so we have our flask down here, and at some point, we know that that flask turned pink. And that's because we put a couple of drops of phenolphthalein in there. When the color change occurs, we call that the endpoint. However, there is something else in titration called the equivalence point. And these aren't the same thing. Sometimes you'll hear them used interchangeably. The equivalence point is where the moles of acid and base are equal. Well, we just figured out that we can figure out the moles of base. So at the equivalence point, we know whatever we calculated for the moles of base is our moles of acid. The endpoint is the color change with an indicator. Ideally, you are choosing your indicator so that the endpoint and equivalence point are roughly at the same spot. So in this case, we're going to assume that phenolphthalein was chosen so that the equivalence point and endpoint are at the same spot. If we just calculated our moles of base, we now know our moles of acid, so we know our moles of HCl. And as I already said, we need to know that volume, so we know whatever the liters of HCl we put in. Well, that looks familiar. We can easily take those two things and calculate our molarity, which is moles per liter. That's how we calculate our unknown concentration. Now we're going to do a practice problem because I did a lot of fake numbers here or vague numbers. Let's do an actual practice problem. So if we have a practice problem here, it says what is the molarity of an unknown hydrochloric acid solution if 65.7 milliliters of a 0.10 molar sodium hydroxide solution was required to neutralize 0.050 liters of HCl. So just as a little bit of a setup, you don't need to draw this when you do these, but I am going to draw it just so we can see what we're dealing with here. We have our flask. This is telling us that we have 0.050 liters HCl in here. Then what we had is that burette that had sodium hydroxide in there, and we used, so whatever we started with and whatever we ended with, that was 65.7 milliliters that we used. And it's 65.7 milliliters of 0.10 molar NaOH. Now, one thing I will always give you a hint on, molarity is moles per liter. So if you ever see milliliters, we are going to be needing to do that conversion. So 65.7 milliliters, we're going to divide that by 1,000, and so we get 0.0657 liters. We have to do that because we want to get moles, and in order to get moles, that molarity right here is moles per liter. Now, this is how much sodium hydroxide, or base, that we used. We can take our 0.10 molar. Now, I'm going to expand this. I didn't do anything different. I just expanded this so that we can see that moles per liter. And what we're going to do is we're going to multiply this by that 0.0657 liters. Now the reason I did this is because I want to show how these units cancel out. I think sometimes it's a little bit hard when we have that molarity that's essentially masking it, but our liters cancel out. And what we get then is 0.006, we have two sig figs, we're getting knocked down here, so I'm going to go to 66 moles, because that 0.10 moles, molar has two sig figs. So we're going to go down to 0.0066 moles. We have our moles. Now we know that this was neutralized, so we hit our equivalence point. When it says it was neutralized or color changed, any of those things, we're going to assume that we hit the equivalence point. So this is not only our moles of base, this is also our moles of acid, because at that equivalence point, moles of acid should equal moles of base. So we have one final step. We are going to take the 0.0066 moles, and remember this is also moles of our HCl then, because it's at the equivalence point. We did calculate this as moles of NaOH, but we're at the equivalence point, so it's moles of both. Now we're going to take that 0.0066, and we know our volume that we started with of HCl. So we are going to put this on the bottom, 0.050 liters. I know there's a lot of zeros, but that's for our sig figs. And we get 0.00657 0.13 molar HCl. Knocked us down to 0.013 because of 2 sig figs. You might have gotten a 0.132 in your calculator, but we're sticking with 2 sig figs here. So in this case, we can use what we know about the sodium hydroxide being added, where that endpoint was in order to neutralize it to get our moles of acid equal moles of base. We need to know how much HCl we started with to get that molarity, and we get 0.13 molar HCl. This is how you're going to do a titration experiment. It really doesn't matter if your unknown is an acid or a base, the steps are the same. The big hint I always give students, if you see milliliters, red flag, make sure you are converting those to liters. So I hope this has helped you with your titration, and I hope this practice problem is a good example of our titration problems.